In this video, we are going to discuss IP addressing, including the structure of the IP address and two schemas for addressing, Classful and CIDR. One of the functions of the network layer in the TCP/IP protocol model is to take data packet from a source all the way to the destination. A packet may pass through several routers on its way to the destination. So network layer has a global responsibility as opposed to the data link layer, which has local responsibility. By local, I mean a data link layer protocol such as Wi-Fi or Ethernet handles the transmission of data frames inside a LAN. But over a global network such as the Internet, the network layer takes a packet and delivers it to the destination outside the current network. The network layer's main function are routing and logical addressing. In order to identify nodes in a network, the network layer assigns each node a 32-bit address called the IPv4. With 32 bits, IPv4 can provide 2 to the power 32, which is about 4 billion addresses. It has another version called IPv6, which has 128 bits, but it has not been quite functional yet. Due to the shortage of IPv4 and the need for guaranteeing quality of service in networks, it is expected to transition to IPv6 in near future. This picture shows the header of IPv4 and its fields. An IPv4 packet has a header and a payload part. The header includes extra information about the packet, such as the version of the IP packet, header checksum, as well as source and destination addresses. The payload holds the main information that should be carried in an IP packet. Each of the fields in the IP header has a predetermined function. For example, the version defines whether the packet is IPv4 or IPv6. Header checksum is used to find errors. Time to live is like a countdown timer, which defines the lifetime of a packet. As a packet passes a node, this number is going to be decremented, and when TTL reaches 0, it is going to be discarded. It prevents packets from moving around forever. Without TTL, network nodes are going to be overwhelmed. And source and destination addresses are the addresses of the sender and receiver of a packet. It is important to note that an IP address does not actually refer to a host. Rather, it refers to a network interface. So if a host on a network has two network interfaces, it must have two IP addresses. Typically, routers have multiple interfaces, and therefore they need a unique IP address for each interface. But most user devices have one interface and they need one IP address. There are two notations to show an IPv4 address, binary and dotted decimal. In binary notation, the IPv4 address is displayed as a 32-bit address. To make the IPv4 address more compact and easier to read, Internet addresses are usually written in decimal form with a decimal point separating the bytes. For example, 172.149.29.2 is the dotted decimal notation of the above address. Before 1993, IP addresses were divided into 5 categories as shown in this picture. Class A allocates 1 byte for network part and 3 bytes for the host part. It ranges from 1000 to 127.255.255.255. Class B has 2 bytes for network and host parts, but Class C allocates 3 bytes for the network and 1 byte for the host. With Class C, 2 to power 24 networks and 2 to power 8 nodes can receive addresses. Class C is used when there are many networks and each has 2 to power 8 or 128 nodes. Class D is used for multicasting, in which a packet is sent to multiple nodes, and Class E is reserved for use in the future. In classful addressing, routing tables in routers would grow fast, and as a result they would overflow. To resolve this issue, classless addressing or CIDR was introduced. It allocates IP addresses based on the need of an organization rather than a block of addresses like in classful addressing. Therefore, the number of entries in routing tables will be kept under control. IP addresses in CIDR consist of two parts, net and host part, and subnet mask determines the number of networks. CIDR notation was invented by Phil Karn in the 1980s. It specifies an IP address, a slash character, and a decimal number. The decimal number is the subnet mask that determines the number of networks. For example, 197.51.100.14/24 includes the IPv4 address 197.51.100.15 and its associated network prefix 197.51.100.0 or and its subnet mask 255.255.255.0, which has 24 1 bits.